about what we call the Cartesian plane, or the XY plane often people call it. Remember that? We use two axes, one horizontal, one vertical. Horizontal is like horizon, back and forth. We often call that the x-axis. The vertical axis, we often call the y-axis, although you don't have to use those letters. So this vertical axis, up and down, think vertical blinds for vertical, to remember which way that is and which way that goes. And then, so that's the y-axis going up and down, the x-axis going across. They intersect at a right angle. And anybody remember what we call that intersection point? It has coordinates 0, 0, but we call it the origin. Remember that? The origin. And so if we want to locate a point in the plane, we can use an ordered pair. The first coordinate is x, the second coordinate is y. Or if we don't use x and y's, it's usually alphabetical order, A, comma, B, or something like that. So, so if you wanted to graph, say, the point 3, 2, you would go from the origin left, or right rather, 3. Right is the positive direction on the x-axis, up is the positive direction on the y-axis. You'd go right 3 and up 2. X equals 3, y equals 2. Oh, so you'd go 1, 2, 3, over 3 to the right, up 2, and you can locate a point in the plane that way. Most people have no idea how important this is to their everyday life. When your navigation system in your car or on your phone tells you where to go, it's using a coordinate system not unlike this. If you want to get anywhere, this is a way to do it, okay? So, you think math isn't related to your everyday life until you get to calculus and beyond that, and then you realize it's everything you like, video games, electronics, your car, everything takes very advanced math to design. Now, this XY plane, the x and y axis divide up the plane into 4 quadrants. Remember that? So we call the quadrant where the coordinates are positive, everything's positive in this upper right-hand corner. We call that the first quadrant, or quadrant 1. And then, remember, we go counterclockwise? So counterclockwise, this upper left-hand quadrant is called quadrant 2. The quadrant where everything is negative, both coordinates are negative, is quadrant 3. And then finally quadrant 4. And that's the Cartesian plane by quadrants. Let's get just a little bit of practice with that. I know you guys know how to do this, but if it's been a while, it doesn't hurt to practice. Let's plot some points. By the way, you can download graph paper. It's just Google image it, and if you like graph paper, download it, make a bunch of copies of it. It's nice when you want to be a little more accurate. Let's plot the points 2, 3, -1, -5, -4, -1, 4 rather, and 3, -2. So 2, 3, we already did one kind of like that. So 2 over 2 up 3. I think we did it 3 up 2, but whatever before, but same sort of thing. So that means x is 2, y is 3, over 2 up 3. What quadrant is that point in? Quadrant 1. Okay, now plot for me, and you guys can do this along with me on your paper. You don't need to draw the grid, just the x, y axis and some maybe some scale marks. Plot with me -1, -5. Go ahead and plot that. And then tell me, I'll do it silently, and then tell me what quadrant we're in when you're done plotting it. -1, -5. So everybody agree it's right here? -1, -5, go left 1, down 5. And somebody said quadrant 3. Actually, let me put it up here. You're in quadrant 3, aren't you? Both coordinates are negative. You're automatically in quadrant 3, right? The point is automatically in quadrant 3. Go ahead and do -1, 4, and then name the quadrant. Do it quietly, though. We'll call on you in a second if you want to speak up. Plot -1, 4. And then plot 3, -2. If it seems too easy, good, right? It's better than being too hard. It'll get hard soon enough. Okay, so everybody understand how I got -1, 4? What quadrant is that one in? -1, 4, that's this one. And that's in quadrant 2, isn't it? 3, -2 is this one. Quadrant 4. There you go. I don't mean to say it's easy. It's easy to make a mistake, right? If you haven't done this in a long time, you might very easily switch the x and y around by mistake. So that's why we go over this, right? Let's think about equations with two unknowns, x and y. You don't have to call them x and y, but usually we do. So check out that equation, 5x minus y equals 3. So here's the thing, it no longer has one solution, right? Like if you were solving 5x minus 2 equals 8, it would have one solution. Add 2 to both sides, divide by 5. It would have one solution. But because there are two unknowns, it doesn't have just one solution. It has an infinite number of solutions. So in this question, in this example, I'm asking, is the ordered pair 2, 7 a solution to this equation 5x minus y equals 3? How do you tell? Do you remember? You plug them in, right? You plug in x equals 2 and y equals 7. And if you get a true statement, if you get 3, then yeah, it's a solution. So let's do that. Let's plug in, let me write down the 5 and the minus, and let's plug in the 2. I'll use a set of parentheses, and then where the x was, I'll plug in the 2. And then it's not even though you don't really need it here, it's not a bad habit to get into, to put a set of parentheses where the unknown was that you're going to plug into. So I'll put a set of parentheses there, and I'm plugging in 7. When you see 5 parentheses 2, that means multiply, right? And that's what 5x means, multiply. So what do you get? You get 10 minus 7. Is that equal to 3? Check. So what's your answer? 2, 7 is a solution. Yes. 2, 7 is a solution. Are there others? There's an infinite number of others. You could just plug in an x value and solve for y, and that's going to be another value, right? Or plug in a y value and solve for x. That's another ordered pair. That's a solution. So the answers here aren't single numbers. The answers are ordered pairs. The solutions are ordered pairs. When you have two unknowns, when you have one unknown, you have one solution, right? When you have two unknowns, you have an ordered pair. It's still one solution, but it's a pair of numbers as opposed to one number. It's an ordered pair. And the idea is we can graph all the solutions. We can make a picture of all the solutions. We can't write down all the solutions, can we? Because there's an infinite number of them. But we can draw a picture that's a pretty accurate depiction of the solutions. And that picture in this case is going to be a line, isn't it? Remember that? It's a linear equation. 5x minus y equals 3 turns out to be a linear equation.